Hello friends, today I am here with my channel Pioneer Tutorial and I have been making videos for you guys. If you want to learn more and more, then please subscribe to my channel and hit the bell icon also. Then you will be able to get the notification of this kind of videos. Today my topic is very simple and it is also of basic electrical nature. Why starters are required for a DC shunt motor? That is my topic right now. So for starter requirement, we need to see about the starting current and starting condition of the DC motor itself. For that, we need to be having some concepts about DC machine. Okay. Now, if we can just having the circuit diagram of a DC machine, then what we can see, it will look like this. A shunt DC motor that I am just drawing. Okay. Now, as it is a motor, the current will be supplied from the terminal itself and the arrow will be in this direction and this direction. Now, here is armature resistance present, that is RA. Then, my voltage equation for this two terminal, it will be a back EMF will be there inside the DC motor and this terminal voltage is VT. The equation will look like Vt minus Eb is equals to Ia Ra. Okay. Now, if in starting condition, what we are saying that at starting, what is happening? N, that is the speed of the motor, that is equals to 0. If in starting condition the N is 0, then we know that Eb is having a formula which is related to N is equals to this. Means if N equals to 0, then Eb is equals to 0. Now what is happening? We can see that if Eb is 0, then Vt is equals to Ia Ra. This Eb is getting 0. Then we know generally in case of our DC machine applications, most of the cases it is around 200 or 220 volts. And Ra is of nature around 0.5 ohms, then the current becomes approximately 440 amperes. It is far more greater value than the rated current. So what can we do? The thing is that we need to arrest this current to a limiting value. We need to make sure that the starting current will not get over the rated value itself. Not by this amount, it is not possible actually to handle. It will burn out. The heat will be so much, it will burn out. What we can do right now, we can insert some resistance in the armature circuit. That is being done in case of starters. In case of a starter, there is a lever. Say this is my lever. Okay. The connections will be, I will be describing a 3-point starter and a 4-point starter in my later videos. But right now, I am just going for the basic itself. Say, one connection circular starter is present and it is looking like this. Now this is the terminal from where the current is getting inside and this is the connecting starter that we are having. Now this is being connected to the armature itself. Now at the starting condition, when the lever is at this position, what we are having, the total current is facing this resistance, which is additive to this armature resistance. Means what? We are actually having more resistance at starting. And when the smaller amount of current flows because of the resistance, then some Eb is being generated inside. Eb is now generated because current has flown. This Eb is now acting here. Means what? This difference is now less than Vt. Vt minus Eb is now less than Vt. Because it was first, it was 0. Now it is less than Vt. Now means what? We can actually decrease the resistance as Eb increases. Now this position, the resistance is much smaller. Again, this resistance will cut out. Like this, we can move the trigger to this position where no starter is connected. Here an electromagnet will be present which will hold the pointer here to the connected here. Then this resistance will not be present, only Ra will be there. So the starter is actually increasing the starting resistance of the armature circuit, which actually reduces the current in terms of which the starting current is inside the rated value. Means what? No condition appears where the burnout situation is present. This was the theory actually, and this is very interesting, and it is applicable to the starters in case of industry as well as practical experimental setups also. Thank you for watching my video.